Hey guys, so we last left off where we were doing quadrantal angles, and quadrantal angles where we had a point on one of our axes and that was a radius of 1. So like this ordered pair was 1, 0. And we remember that we saw sine went with y, cosine went with x, and then tangent was sine divided by cosine. So today we're going to talk about angles that are anywhere, not just on the axes. So what we're going to look at is these steps to success. First thing you're going to do is plot the given ordered pair. So you have to kind of know how to plot ordered pairs. Your ordered pair is going to be x, y. You know how to do that. Positive is to the right for x and up for y, and the negative is to the left for x and down for y. So you're going to plot your ordered pair. So let's say my ordered pair is right here in this first quadrant. Then you're going to draw a line connecting the point to the x-axis, so straight down, and one connecting, I always do that, one connecting it to the origin. So now this right here, this is the triangle that we're talking about. Your angle is always right there, that central angle always right there by the origin, and then your radius is going to be this piece here. Since we drew that line straight down to the x-axis, we have a right triangle. So that's what your triangle would look like, and then your x would be positive and your y would be positive. Now you have the opportunity to draw ordered pairs in all 4 quadrants. So if your ordered pair was in quadrant 2 here, you would draw straight to the x-axis, to the origin, and then this would be our triangle. If you had a point in the 3rd quadrant, like here, drawing that line straight to the x-axis and then to the origin, still with that angle right there in the center. And then finally, if you had a point in the 4th quadrant, you would draw straight to the x-axis and to the origin with that angle in the center. So looking at these kind of look like a bow tie. So if I were to recreate that axis, one of our angles is going to be a piece of the bow tie. I messed up my bow tie. Okay, so your bow tie is looking like that. That's going to be what your triangles look like, one of those 4 pieces. So let's go ahead and give it a try. So looking at example 1 here, we have the ordered pair -4, 3. It's asking us to evaluate trig functions given this point, exact answers only. So exact answers are telling us we have to use radicals if we were given that option, no decimals. So the first thing we're going to plot the given ordered pair. So I'm going to go ahead and draw my axes here. -4, 3 means left 4 and up 3, so it's going to be in quadrant 2. Connect the point to the x-axis and to the origin. And so this is the theta, the angle that I'm talking about. So -4, 3 means that -4, I went left 4, this is -4, and I went up 3, so that's going to be +3. Now what we're going to want to do is find the hypotenuse. You're going to do that by using Pythagorean theorem. Your hypotenuse is always positive, as you see in those steps, so we'll do -4 squared plus 3 squared equals r squared. So 16 plus 9 equals r squared. 25 equals r squared, which means that r is 5. So my radius here is 5. Now you might have known that because that's a Pythagorean triple, a 3, 4, 5 triangle. And if you do know that, then you can go ahead and bypass that Pythagorean theorem right there. So now based off of my angle here, we can do our sine. Sine is opposite over hypotenuse, so that would be 3 over 5. Remember cosecant, all you're going to do is flip that fraction, so we'll make that 5 over 3. Cosine is adjacent over hypotenuse, so adjacent is -4 over hypotenuse of 5. And my secant is going to be 5 over 4. Now when we're doing the negative, I usually just leave that on the outside or on top. We don't really write 5 divided by -4. That just looks kind of weird. And then finally, tangent is opposite over adjacent, so 3 over 4, and that fraction is negative. And we'll go ahead and flip that for cotangent to get -4 over 3. And that's it. We've evaluated the 6 trig functions. Okay, so if we look ahead at example B now, the ordered pair is 3, -3, so we can go ahead and sketch that. So right 3 and down 3 would mean the point is in this 4th quadrant, connecting that point to the x-axis and then to the origin. So 3 is +3 and -3 is why I went down 3. So now what we're going to want to do is find that hypotenuse again by using the Pythagorean theorem. So 3 squared plus -3 squared equals r squared. Notice I put that -3 in parentheses so we could be really careful when we're squaring that. And then we can go ahead and make that 18 equals r squared. take the square root, and simplifying our radical exact answers only. So that's going to tell us that we have 3 radical 2 for r. Now you might have noticed that this is a special right triangle because we have both side lengths. The distance is 3. So these sides are actually congruent, which means it's a 45, 45, 90 triangle. So you could have gotten that the hypotenuse is going to be 3 radical 2 by using your properties and just multiplying by radical 2. That would have been fine. Now our angle is always the central angle here. So if I want to do sine, sine is going to be opposite over hypotenuse. So opposite is going to be -3 over hypotenuse, 3 radical 2. So go ahead and simplify that down to -1 over radical 2. And at this point, since I've simplified that, I'm going to go ahead and find my cosecant and flip that to be radical 2 over 1 and negative. So my cosecant is actually negative radical 2. That helps us out a little bit so we don't have to rationalize 2 times. Over here, though, I can't leave this radical in the denominator, so I'm going to multiply by radical 2 on top and bottom to get my final answer of negative radical 2 over 2. Then I'm going to go ahead and do cosine. Now I'm going to notice that cosine is so very similar, except it doesn't have the negative. So I'm going to start with 3 over 3 radical 2, which is going to be a positive 1 over radical 2. So flipping that for my secant, that's going to just become positive radical 2. And then rationalizing again is going to give me a positive radical 2 over 2. And then finally, tangent, opposite over adjacent. So my opposite is -3 over adjacent is +3. That's going to simplify to -1. And then I can go ahead and take the reciprocal of -1 to get 1. Hey guys, so we last left